In this video, we're going to talk about quadratic equations. So, we will first start with solving quadratic equation by factorization. So, an equation containing a second degree polynomial is called a quadratic equation. For example, equations such as 2x squared plus 3x minus 1 equal to 0 and s squared minus 4 equal to 0 are quadratic equations. Now, they are used in countless ways in the field of engineering, finance, and biological sciences, and of course, mathematics. So often, the easiest method of solving quadratic equations is by factoring. Now, factorization means finding the expression that can be multiplied together to give the expression on one side of the equation. So if a quadratic equation can be factored, it is written as a product of a linear terms. So solving by factoring depends on the zero product or the zero product property, which states that if a dot b is equal to 0, then a is equal to 0 and b should be equal to 0, where a and b are real numbers or algebraic expression. So in other words, if the product of the two numbers or the two expressions equals 0, then one of the numbers or one of the expression must be equal to 0, because 0 multiplied by anything equals to 0. So multiplying the factors expands the equation to a string of terms separated by plus or minus signs. So in that sense, the operation of the multiplication and thus the operation of the factoring. So for example, expand the factored expression, which is x minus 2 multiplying x plus 3 by multiplying the factors together, right? So when you multiply this, you get x squared plus 3x minus 2x minus 6, which when you simplify, you should get x squared plus x minus 6. So the product is a quadratic expression. Set equation to 0, which is when you set this equation, which is x squared plus x minus 6 equal to 0, it's a quadratic equation. If we're to factor the equation, we will get back the factors we just multiplied right now from here, from the starting. If we were to factor this equation out, we will get back x minus 2 multiplying x plus 3. The process of factoring is a quadratic equation. It depends on the leading coefficient. So this is a leading coefficient. So what is the leading coefficient of x squared? It is 1. So if you have 4x squared plus 2x plus 3, the leading coefficient is 4. Right, so that's what we are talking about. What that is leading coefficient. So whether it is 1 or another integer, we look at both situations. But first, we want to confirm that the equation is written in the standard form. So what is the standard form? The standard form of quadratic equation is ax squared plus bx plus c equal to 0, where a, b, and c are all real numbers. And remember that a can never be equal to 0. So the equation that we have a x squared plus x minus 6 equal to 0 is in the standard form. So we can use the zero product property to solve quadratic equations, in which we first have to factor out the greatest common factor, which is a GCF, and for any equations that have special factoring formulas as well, such as the difference of squares both of which we will cover later, or we have already covered in factoring polynomials, right? So with this one, we have the zero product property and quadratic equation. So the zero product property states that if a dot b is equal to 0, then a should be equal to 0 and b should be equal to 0, where a, b are real numbers or algebraic expressions. So a quadratic equation is just an equation containing a second degree polynomial. For example, what we just stated, which is ax squared plus bx plus c equal to 0, where we stated that a, b, and c are all real numbers, and remember that a can never be equal to 0, which is in the standard form, right? Now let's talk about solving quadratic equation with a leading coefficient of 1, right? So as we stated with the equation of x squared plus x minus 6 equal to 0, the leading coefficient, or the coefficient of x, is 1. So we have one method of factoring quadratic equation in this form. So how do we do this? Now, first of all, what you need to do is find two numbers whose product equals to c and whose sum equals to b. So you find two products. For example, when you come to this part, so we are going to find two numbers whose products, so the product should be equal to c. So this is c, and the sum should be equal to b. The b is the number in front of this x here, right? Now the second thing that we need to do is to use these numbers to write two factors of the form x plus k or x minus k, where k is one of the numbers found in step 1, right? Now the last thing that we need to do is solve using the zero product property by setting each factor equal to 0 and solving for the variable. Don't worry, let's look at some example with the property that, or with the example that we stated earlier on. So we use the example x squared plus x minus 6 equal to 0. Now let's see how we are going to do this. Now we said first of all, we need to factor x squared plus x minus 6 equal to 0. So we are going to look for two numbers whose property, or whose product, is equal to -6 and whose sum is equal to 1. So let's go ahead and do that. So we begin by looking at the possible factors of -6. So let's state down the possible factors of -6. So we will have 1 dot -6, -6 dot 1, 2 dot -3, 3 dot -2. Now we can see that the last pair, which is 3 dot -2, sum to 1. So when you sum this last one here, which is 3 plus -2, we should get 1. And when we multiply it as well, we should get -6. So 3 dot -2 should give us -6, right? So to solve this equation, we use the zero product property. So now that we've gotten the 3 and -2, we are going to use to write that. So with this one, note that the only one pair of numbers will work, right? So then we write the factors. So we are going to have x minus 2, then x plus 3 equal to 0, right? Then we use the zero product property to solve it, as we said. So we will have, let me go down here. So we will have x minus 2, x plus 3 equal to 0, where we have x minus 2 equals to 0, where x should be equal to 2, or x plus 3 equal to 0, where we have x to be negative 3. So the two solutions are 2 and negative 3. We see how the solution relate to. Now let's look at how this solution relate to the graph. So I have a graph here, right? I have my graph here. Let me clean this one and come back to, yeah. So I have my graph here. So now let's graph that, the solution onto that. Now we have negative 3. So let's plot that. So we have negative 3 and we have 2. That's our solutions. Now let's plot the quadratic graph on that. So when we do that, we will see we have, it's gonna pass through that and pass through the 6 and come back, pass through. It's not that perfect because it's this raw sketch, right? So this is what we are going to have. This is a sketch, which is y should be equal to x squared plus x minus 6. That's the minus 6 right there, right? We will talk about graph of quadratic equation, right? Now, example 2, we have x squared plus 8x plus 15 equal to 0. Now let's do it again. We find two numbers whose product is equal to 15 and whose sum is equal to 0. Now let's list the factors of 15. So with that, we are going to have factors of 15. Factors of 15. So that will be 1.15, 3.5, negative 1 dot negative 15, negative 3 dot negative 5, right? Then the numbers that add to 8 are 3 and 4. We can see from that, and 5. That when you add, we should get 8 is 5 is 3 and 5. Then we write the factors and set each factors equal to 0. So with that, we should get x plus 3, then x plus 5 equal to 0, right? So we have x plus 3 equals 0, where we have x to be negative 3, then x plus 5 equals 0, we have x to be negative 5. Very simple to do. Very, very simple to. So therefore, the solutions are negative 3 and negative 5. Very simple to do. Now let's talk about another thing here, solving a quadratic equation by factorization when the leading coefficient is not 1. There's another thing. Previously, we have talked about solving quadratic equation when the coefficient is 1. Now let's look at when the coefficient is not 1. How do we deal with that? So let's talk about that. Now, when the leading coefficient is not 1, we factor a quadratic equation using the method called grouping. So we've covered the grouping method of factorization in our previous video. So if you haven't watched that, I'll encourage you to go back and watch how to factor by grouping. So which requires 4 terms. And with the equation in the standard form, let's review the grouping procedure as we talk about. So I'll just go through by talking about it. So the first thing that we need to do with the quadratic equation in the form of ax squared plus bx plus c equals to 0, what we need to do is to multiply. I'm not going to write everything. Multiply a dot c. That's what we need to do. Then the second thing that we need to do is to find two numbers whose product equals to AC. Find two numbers whose product equal to AC and whose sum is equal to B. So the sum should be equal to B and the product should be equal to AC, right? And rewrite the equation by replacing the BS term, which is right here. We have to replace. So replace the BS term with two terms using the numbers found in step 1, right, as coefficient of x. And the fourth thing that we need to do is to factor the first two terms and then factor the last two terms. And the expressions in parentheses must be exactly the same as to use grouping, right? And the fifth thing that we need to do is to factor out the expressions in parentheses. The last thing that we need to do is to set the expression equal to 0 and solve for the variables. I know this is kind of complicating, but let's look at some examples here. Now, with my first example, let me firstly write the example here. So let's solve this question. So 4x squared plus 15x plus 9 equal to 0. Let's solve this and see how we do it. Now, we said the first thing that we need to do is to multiply AC, right? What is our A? So our A is 4 and our C is 9. So we are going to multiply AC. So multiply AC, we have 4 multiplying 9, which is 36, right? Then we list the factors of 36. So factors of 36. So the factors of 36, we have 1.36, 2.8, 3.12, 4.9, 6.6. So these are the factors of 36. Now you can see that the only pair of factor that sum to 15 is 3 plus 12, right? 3 plus 12. So this factor here, or this pair here. So we have to rewrite the equation replacing the b term, right, which is 15x, with two terms using the 3 and 12 as coefficient of x. So then we factor the two terms and then factor the last two terms. So let's do that. So we write 4x squared plus 3x plus the 12x. That's the pair that we got. These are the pairs that we got here. So plus 9 equal to 0, right? Then we will have x out, 4x plus 3 out. Then we have 3 out, then 4x plus 3 equals to 0, right? So what we just did, we find the factors of 36. Then we got a pair that when we multiply should give you, when we add, it should give you 15, which is the b term. Then we replace that with that. So at the beginning, we had 15x, right? So we are going to replace the 15x with 3 and 12, with the x attached to each of the numbers here, which is 3x and 12x there. And we had that. And we are going to factor out. So factoring out, we have x coming out. We have 4x plus 3 plus factoring this 1, 2 out. We have 3 out. Then we have 4x plus 3 equal to 0. Then we group them. So we have x plus 3 multiplying 4x plus 3 equal to 0. Then we solve for the variables, which is x plus 3 equal to 0. Then we have x equal to negative 3, or x 4x plus 3 equal to 0. Then we have 4x equals to negative 3. Find x, divide both side by 4. We have x equal to negative 3 on 4, right? So this is our solution. So therefore our solutions, the solutions are negative 3 and negative 3 on 4. We can also try to graph this on the graph. We will talk about quadratic graphs, so we shouldn't worry about graphing here at all, right? So this is the end of this video, and I'll see you in my next video. Thank you for watching.